Water taxi safety. The central limit theorem. Passengers die when a water taxi sank in Baltimore Inner Harbor. Men are typically heavier than women and children, so when loading a water taxi, assume a worst-case scenario in which all passengers are men. Assume that weights of men are normally distributed with mean of 182.9 pounds and a standard deviation of 40.8 pounds. The water taxi that sank had a stated capacity of 25 passengers, and the boat was rated for a load limit of 3,500 pounds. Notice that the original distribution was given normal already, and we were told that it is normally distributed with the mean of 182.9 and the standard deviation of 40.8. In symbolic form, mu equals 182.9 and sigma equals 40.8. And these are the parameters that tell us something about the population. Part A. Given that the water taxi that sank was rated for a load limit of 3,500 pounds, what is the mean weight of the passenger if the boat is filled to the stated capacity of 25 passengers? Simply put, if the stated limit is 3,500 pounds and if there are 25 passengers, then the mean weight of the passengers x bar equals the total 3,500 pounds divided by the number of passengers 25, and in this case we will get 140 pounds. This is 140 pounds per passengers, and that is the mean weight or the average weight in this case. Part B. If the water taxi is filled with 25 randomly passengers, what is the probability that their mean weight exceed the value from part A? Now, this question is asking us about the mean of the sample. What is the probability that their mean weight or the average weight, the average of the sample of size n equal 25? And so we will use the central limit theorem or the sampling distribution in this case. There's no need to check for normality because we were given the normal distribution to start out with. First, we draw the bell-shaped curve, label the mean and the standard deviation. But this is the sampling distribution of the sample mean. The mean mu x bar equals the mean of the population, which is 182.9. The standard deviation, however, it is the standard deviation of the population divided by the square root of n. This is 40.8 divided by the square root of 25. But the square root of 25 is 5, so this is 40.8 divided by 5, or 8.16. So with this sampling distribution, the mean is 182.9 and the standard deviation is 8.16. What is the probability that the mean weight exceed meaning greater than? The value that we are interested in this case is 140. That is the number that we got from part A. 140 is a number on the left hand side of 182.9. And so we draw the vertical line, and since it is exceed that we're looking for, we shade everything on the right hand side. Exceed means more than. Using technology, we compute the probability that x bar is greater than 140 once we input the mean of 182.9 and the standard deviation of 8.16. Not 40.8 but 8.16, because we're looking for the probability that the mean exceeds 140. Statcrunch normal calculator or any normal calculator will give us the probability of 0.99999 and so on, and this is almost 1. If it's almost 1, then it is almost certain that the probability that the mean or the average weight of those 25 passengers exceeds 140, and that is not safe. Before we move on, let's see how we use the graphing calculator or any technology to compute the probability. First, we need to input the mean. The mean in this case is 182.9, and that is the population mean, the mean of the population. The standard deviation of the sampling distribution, in this case with the sample size of 25, we computed that the standard deviation, the standard error is 8.16. So we input 8.16. We want to find the probability exceeds, so we select greater than or equals and type in the values 140, that is the mean of that particular sample in question, and hit compute. Again, the calculator gave us 0.999999, and that is almost 1. Part C. After the water taxi sank, the weight assumption were revised so that the new capacity became 20 passengers. If the water taxi is filled with 20 randomly selected men, what is the probability that their mean weight exceeds 175 pounds? Where do they get 175 from? The boat capacity is still 3,500, but this time they lower the number of passengers to 20, so average 3,500 divided by 20 is 175. We're looking for the probability that the mean weight x bar exceed 175 pounds in this case, but we cannot use the same distribution because the sample size is no longer the same. This time, we will need to find the new mean and the new standard deviation. But the new mean is still the same 182.9, the same as the mean of the population. The standard deviation of this sampling distribution is now the old standard deviation or the standard deviation of the population divided by the square root of the sample size 20. And 40.8 divided by the square root of 20 is 9.1232. The number in question is 175, so we would draw 175, which is on the left-hand side of the mean, 182.9. And we want to find the probability that the average exceed this number, and so we will shade everything on the right-hand side of this number. Using technology, we input the mean, 182.9, the standard deviation, 9.1232. Not 8.16, not 40.8, but the standard deviation is now 9.1232. The standard error, 9.1232. We select the inequality greater than or equals. It doesn't matter because this is a continuous distribution. The value that we're interested in is 175. The calculator should give us a probability of 0.8067. And that is the probability that after they lower the number of passengers, the chance that the average weight of those passengers is more than 175 is 81%. Next question, is the new capacity of 20 passengers safe? The question about safety is subjective. In this case, 81% chance that the mean weight exceed the average 175 pounds. This is the same as saying the probability that the total weight that is exceeding the capacity of 3,500 pounds is 81% or 0.8067. And so there is 81% chance that it goes over the capacity, and for safety purpose, that probability is simply too high. And so we would conclude that this is not safe enough for anyone who want to take the water taxi.